The silkworm, Bombyx more, is reared for the sole purpose of cocoon production. To spin its cocoon, the silkworm excretes a silk substance contained in its two seraphic glands in the form of a continuous and long proteinous filament. The unwinding of this fine silk filament from a cocoon or a bunch of cocoons to form a single thread is termed as reeling. This reeling activity is crucial and often considered to be the very backbone of the silk industry, as raw silk quality and cost depends largely on reeling and preparatory methods and devices. Therefore, care is essential at every stage in this process, from cocoon selection and preparation to reeling and re-reeling. Being the basic raw material in the production of raw silk, good quality cocoons are of prime importance for reeling of quality silk. To ensure commercial reelability, cocoons are best bought from regulated cocoon markets, where defective cocoons have already been sorted and separated. The physical characteristics of the cocoons under consideration merit careful examination, as these are important indications of their commercial reelability. Though cocoons come in various colors, color is not of vital importance, as coloring pigments are present only in the sericin layer, which is removed during decumming. The shape of the cocoon, however, must be taken into account. Spherical, oval, or moderately constricted cocoons ease reelability. Cocoons with a deep constriction in the middle or with pronounced points tend to inhibit reeling. Cocoon size is important too, as it indicates quantity and percentage of silk filament. The selected cocoon lot should be of uniform size. Compactness or hardness of cocoon is another important physical characteristic that bears consideration. Cocoons that feel firm and elastic but do not collapse are best, as they yield their silk readily on reeling. Excessive floss too is undesirable, as it merely adds to waste and cost. Ideally, cocoons should be finely granulated. Coarse and wrinkled cocoons normally have thick baves. Another important commercial characteristic that must be considered is the cocoon weight. It is this that determines cost and the estimated rendita. Of even greater importance than cocoon weight is shell weight and ratio, as it is the shell that yields the silk for reeling. Shell weight and ratio differs in various types of cocoons. However, it is easily calculable. The calculated value gives a fair indication of the quantity of reelable silk a cocoon lot is likely to yield. The length of the silk bave is also of commercial importance, as short filament length on cocoons leads to higher rendita, increased waste, and decreased productivity. Ordinarily, only 75 to 80% of the shell comprises of reelable filament, as the outer floss layer is coarse and entangled, and the innermost pelade layer is too thin and weak. The percentage of recovery is normally greater in bivoltine cocoons. Filament denier must also be considered. Even within a cocoon, denier size is higher or coarser in the outer layers and thins down progressively towards the innermost layers. Allowing for this natural diminution, tolerance limits for commercial raw silk are specified thus. Other important commercial factors that merit consideration are reelability and raw silk percentage. Gauging this requires experience, but generally, Both reelability and raw silk percentage are higher in bivoltine cocoons. Once suitable cocoons have been identified, they need to be prepared for reeling. The first step in this process is stifling and conditioning. Fresh or green cocoons cannot be stored as the pupae within soon transform into moths. These emerge by piercing the silk shell and render the cocoons unreelable. Stifling kills the pupae inside the cocoon without interfering with the structure of the silk shell around it. Various methods are employed for stifling, but the most popular are sun drying, steam stifling, and hot air drying. Sun drying consists of killing and drying pupae by prolonged exposure to scorching sun. Though simple and cheap, this is possible only in hot climates. Besides, exposure to bright sunlight over long periods adversely affects babe strength and impairs reelability. Steam stifling is another comparatively more efficient method of stifling. Here, fresh cocoons are exposed to hot and wet steam for predetermined periods. For small quantities of cocoons, steam stifling can be done in bamboo baskets with loosely woven bottoms that allow for easy access to steam. 10 to 15 kilograms of cocoons are loosely filled in a basket, which is then covered by a wet gunny cloth. The prepared basket is placed over a vessel of boiling water. It is important to ensure that the cocoons are not in direct contact with the water. The steam from the vessel fills the basket, and in 20 to 30 minutes, the pupae within the cocoons are killed. Small quantities of cocoons can also be steam stifled in metal barrels. For larger quantities of cocoons, stifling is best done by chamber steaming. Depending on the chamber capacity, 25 to 30 kilograms of cocoons are steamed simultaneously in these special chambers equipped with trays. Cocoons are spread in a 2-inch thick layer. Steam is passed through the chamber for 15 to 20 minutes and then cut off. The trays are then aired. Steam stifling, either by basket, barrel, or chamber methods, is practiced by many small reeling units. However, it has various drawbacks. Steam stifled cocoons are soft and wet. They can be easily damaged by handling. They are also highly susceptible to mold attack. Moreover, the dead and wet pupae within the cocoon decompose rapidly and can stain cocoon shell. To prevent this, careful handling, adequate airing, and drying over 3 to 4 days is essential. To overcome the drawbacks of steam stifling and enable safe, prolonged storage, cocoon stifling is best done by the hot air method, either by batch type or conveyor type drying. Here, the cocoons are heat stifled and dried simultaneously. Cocoons are placed in thin layers on shelves within the stifling chamber, which is equipped with a fan for hot air circulation and an exhaust system for moisture evacuation. Air, heated either by steam or electricity, is passed through the chamber for 5 to 6 hours. Temperature is gradually reduced from 100 degrees centigrade to 60 degrees centigrade. This system causes dryage to the extent of 50 to 55%. 15 to 16% dryage allows for better reeling, but a high dryage level is advantageous as it facilitates safe and prolonged storage. Alternative stifling methods tried are infrared rays, cold air, radio waves, and poisonous gases. During storage, cocoons must be spread in thin layers on racks and turned periodically to prevent mold. The storage room must be well ventilated and protected from insects, rats, and ants. Prior to reeling, cocoons must be deflossed, as superfluous floss obstructs reeling. However, this operation must be taken up just before reeling only, as floss serves as a protective covering during the stifling and storing stages. Deflossing can be done manually. Though laborious, this ensures that only the required quantity of floss is removed. Simple appliances and hand or power-operated machines can also be used. Even though cocoons may have been sorted prior to marketing, after deflossing, another sorting is required, as cocoons may have been damaged by mold and handling during stifling and storage. These, as well as other defective cocoons, must be separated. Next, cocoons must be graded according to size by hand. Only uniform size cocoons offer scope for quality silk reeling. After grading, the reelable cocoons must be cooked to soften the sericin, which holds the intricate bave windings of filament together. This cooking operation is crucial and needs trained expertise, as both overcooking and undercooking affect reelability and quality of raw silk. The quality of water used for cooking is of prime importance, as it has a direct impact on raw silk yield and luster. Ideally, cooking water should be colorless, limpid and odorless, with a pH value of 6.8 to 7.4. Total hardness may range between 50 to 90 ppm. Cooking and reeling water must be tested and treated if necessary, using chemicals and softening agents. Cooking itself can be carried out by various methods. The most common is the open pan type method, in which cocoons are cooked in open pans for 3 to 5 minutes. 150 to 200 cocoons per batch ensure uniform cooking. Cocoons are cooked just to the right degree, and the cooking water changed for every 2 to 4 kilos of cocoons. This method has been found suitable for steam-stifled multi-voltine cocoons. Bivoltine cocoons, however, have very compact shells that do not allow easy permeability of water. To allow uniform cooking of the inner layers too, bivoltine cocoons require either the 3-pan system or the pressurized system of cooking. In the 3-pan system, cocoons are filled in wire mesh cages and cooked in 3 cooking basins in water at different temperatures, ranging from 65 degrees centigrade to boiling. The sequence is simple and allows uniform cooking of both inner and outer layers. It is economical and can be practiced in cottage basin and small multi-end reeling units. However, in bigger filature units, where cocoon requirements are large, the pressurized cooking system may be adopted. The 2 methods generally used for pressurized cooking are the cylindrical cocoon boiling system and the conveyor system. The cylindrical cocoon boiling machine is similar in principle to the conveyor system. The conveyor system is ideal for large filature units. Power-driven, this machine comprises mainly of an endless chain conveyor that carries a series of brass wire cages that hold the cocoons through several chambers. Within these chambers, the cocoons are alternatingly cooked in hot water at specified temperatures and steamed. The process is hazard-free and cooking is uniform through all layers in all cocoons. This enhances reelability and helps improve raw silk quality. Pressurized cooking is also advantageous, as during the process, the air within the cocoon is expelled and replaced by water. Such cocoons sink in the reeling water and yield their silk bave more readily than floating cocoons. After cooking and before reeling, brushing is required to once again remove surface floss and locate the reelable end of the cocoon. Brushing can be done manually in the cooking basin itself with either a soft stick, prong or brush. In semi-automatic or automatic reeling machines, it is done mechanically. Once brushed, the cocoons are ready for reeling. In India, there are 3 distinct reeling devices in popular use: charakka, both traditional and improved, cottage basins, and multi-end basins. More than 50% of the silk produced in India is from the charakka sector. A simple device, the traditional charakka, requires little investment and skill. It facilitates reeling from even inferior quality cocoons. But the finished product is coarse and substandard. Working conditions too are extremely hazardous. To upgrade silk quality and better working conditions, an improved version of the traditional charakka has been developed. A smokeless oven improves work environment, while provisions like a slump catcher and a travel air crusher help enhance yarn quality. However, even the improved charakka is unsuited for production of high-quality silk, especially from bivoltine cocoons. A device that allows reeling of comparatively better quality silk is the cottage basin, a variation of the charakka designed on the principle of the Japanese multi-end reeling machine. The cottage basin accounts for nearly 40% of the total raw silk production in India. Here, cooking and reeling are done separately. The hot water reeling basin is attached to the reeling bench. Each basin has 6 to 8 ends. Though more efficient than the charakka, even the cottage basin is generally hand-driven and requires considerable handling skill. Subsequently, good quality is hard to achieve. Far more efficacious is the multi-end reeling machine. Being power-driven, this machine compensates for skill through mechanics and ensures high reelability of superior quality yarn. Here, each basin consists of 10 ends. The multi-end reeling machine enables efficient reeling of nearly all types of cocoons. It accounts for almost 10% of the country's total raw silk production. The quality of reeled silk is far superior to that of the charakka or cottage basin. Machine cost is compensated by enhanced productivity. Requirements of skill are minimized and working conditions rendered hazard-free. Some large filature units in the country are also equipped with semi-automatic and automatic reeling machines. However, only good quality bivoltine cocoons can be reeled here. After reeling, raw silk quality is further enhanced by re-reeling. For smooth re-reeling, silk reels must be first immersed in water with a wetting agent at room temperature. Moisture is removed during re-reeling by the provision of steam pipes below the swift. Re-reeling improves quality by eliminating gum spots and minimizing loose ends, slumps and waste particles. It also facilitates preparation of standard-sized hangs of 150 centimeters periphery. After re-reeling, the raw silk should be properly laced. Ensure against breaking of thread when removing the silk from the swift. Re-reeled silk is then made into skeins. Each skein should be about 30 centimeters in length. The standard weight of a skein for 20 to 22 denier is 60 to 70 grams. Higher weight up to 120 grams is being preferred by the power looms. For marketing, skeins are made into books on a bookmaking machine. Each book should have about 30 hanks weighing 2 kilograms. The silk is now ready for testing, grading and marketing. Testing and grading serves as a valuable aid to those engaged in silk yarn processing and weaving. In India, silk is graded by the procedures laid down by the Bureau of Indian Standards. Yarns are tested for evenness, cleanness, denier, winding breaks, tenacity, elongation, and cohesion. Based on these tests, silk is graded. Tested and graded silk goes a long way towards ensuring quality and is particularly important for the production of quality silk fabrics. The filature industry produces substantial quantities of waste which can all be put to effective commercial use. Silk waste can be utilized by the spun silk industry. Dead pupae are rich in protein and fat content. They can be used for oil extraction and the remains fed to fish or poultry. Double cocoons, not fit for standard reeling, can be used for manufacture of dupure silk. If quality is maintained, these wastes get high returns for the reeler and aid in lowering the net cost of raw silk production, which in itself is a painstaking enterprise that nevertheless earns rich rewards. For uniform, clean and neat raw silk is in demand the world over and fetches a truly high price. But to ensure these returns, care at reeling is vital at every stage, from cocoon selection and preparation to reeling and re-reeling.